Hello, I'm Dave Tegeder, a consultant to the U.S. Soybean Export Council, and welcome to this portion of the Soy Excellence Center's ongoing educational series. My presentation will focus on Ohio Lake soybean oil, one of the U.S. soybean industry's most exciting new products. Today, I'll be covering an overview of its development, functional characteristics, and applications in food service and food manufacturing. With Ohio Lake soy's significantly different fatty acid profile and excellent stability, we're really talking about a new premium oil for the food industry that you can market in addition to commodity soybean oil. In order to understand the benefits of Ohio Lake soy, you first need to understand what makes it have superior functional properties. Regular soybean oil is comprised primarily of polyunsaturated fats. Poly means multiple. And it's these multiple or many double bonds that makes regular soybean oil less stable. When an oil is exposed to heat, air, moisture, or reactive metals, these double bonds start breaking apart, and that is how an oil degrades and becomes rancid. In the past, refiners used to partially hydrogenate the oil to improve its stability and functionality, but that created trans fats, which were linked to coronary heart disease. So the food industry rapidly moved away from partially hydrogenated oils in favor of more stable liquid oils having no trans fats. So what were the factors that led to the development of Ohio Lake soybeans? The most significant was the U.S. Food and Drug Administration's 2006 trans fat labeling law that required food companies to report the trans fat content on all packaged foods. This led to companies quickly moving away from using partially hydrogenated products in their ingredients. The final blow was FDA's 2018 ban on all partially hydrogenated oils, which completed their total removal from the mainstream U.S. food supply. Initially, this was a huge dilemma for the U.S. soybean industry, since nearly 50% of the soybean oil used in food was in the form of partially hydrogenated products. Soy's overall market share in food applications declined from a high of 80% to the mid-50s range we see today. Fortunately, the U.S. soybean industry recognized the critical need to recapture these lost markets, along with developing new uses, including Ohio Lake soy-based shortenings and non-food applications such as bio-based petroleum alternatives. In addition, with advances in plant breeding technologies, the soybean seed industry had been developing new Ohio Lake traits that changed the fatty acid profile inside the soybean seed. As you can see, we now have a soybean oil with 75 to 80% oleic or monounsaturated fat, with less than 10% residing in the polyunsaturates and a 20% reduction in total saturates. So Ohio Lake soy is truly a new and completely different oil that allows you to expand your soy product line offering. So why is this important? When we look at the relative rate of oxidation in fatty acids compared to oleic or monounsaturated fat, linoleic acid is 40 times faster at oxidizing, and linolenic acid is 98 times faster at going rancid. This is why commodity soy typically had to be hydrogenated in order to have enough stability to be used by food companies. With most of Ohio Lake soy's oil profile now residing as the more stable monounsaturated fat having only one double bond, this provides a significantly improved heat and oxidative stability over commodity soy and other vegetable oils. I'd also like to point out that when we compare Ohio Lake soy to olive oil, you can see the fatty acid profiles are almost identical, except that Ohio Lake soy now has less saturated fat than that of olive. It's also important to note that all of the changes made within the soybean were only to the oil's fatty acid profile. When we analyze the protein and amino content from Ohio Lake soybeans, it's nutritionally identical to commodity soybean meal when fed to livestock. In fact, in the US, all meal resulting from crushing Ohio Lake soybeans is simply blended and marketed as commodity soybean meal. You will also see the same slight seasonal and seed variety fluctuations as with commodity soybeans. There are currently 3 different Ohio Lake soybean traits in various stages of commercial development and availability. While they all have an oleic content in the mid to upper 70% range, there are slight variations in the rest of their fatty acid profiles along with different seed technologies used in their development. Corteva Agrisciences Plenish trait, marketed under its Pioneer seed brand, was developed through biotechnology and is the most widely grown and commercially available at this time. Missouri Soy's soyleic trait is a non-GMO, but it has a slightly wider variation in its fatty acid profile and is just beginning to be commercialized. And Calixt's Calino trait was developed through genome editing, but it is only being targeted for the use in the U.S. domestic market at this time. So the U.S. soy industry has high oleic varieties suited to whichever attributes your customers value the most. So what are the performance benefits of high oleic soy? Well, for starters, it's a healthier oil with 0 grams of trans fats per serving, 20% less saturated fats, and high in heart-healthy monounsaturated fat, similar to the amount found in olive oil. It also has 2 to 3 times longer fry life, which translates into fewer oil changes, annual oil cost savings, and less packaging material to dispose of afterwards. A cleaner, lighter flavor. Because the oil is so stable, there's less of a residual oily flavor, which allows the inherent flavor of the food to be tasted, not that of the oil. It also allows for opportunities to be blended with other oils. A higher smoke point. We typically see approximately 10 degrees higher when compared to commodity soy or high oleic canola or sunflower oils. Easier cleaning. Reduced polymer formation on hot cooking surfaces leads to less gummy buildup on fryers and equipment. For packaged foods, we see a 3 times longer shelf life. And a trend we are seeing today in the U.S. food market is consumers wanting foods made with simpler, more easily understood ingredients and having no artificial preservatives. High oleic soy's excellent oxidative stability allows a food manufacturer to remove the synthetic preservatives previously needed in order to achieve the required shelf life for their finished products. The Oxidative Stability Index, commonly referred to as the OSI test, is used to compare an oil's relative resistance to oxidation. In this test, just remember, the higher the number of hours, the more stable the oil. As you can see from the bottom of this chart, most commodity oils such as corn, canola, and soy go for only about 6 to 11 hours. High oleic canola and sunflower oils top out in the mid to upper teens, and palm olein ranges in the low to mid 20s, while high oleic soy goes greater than 25 hours and typically reaches 30 hours or more, getting into the stability range previously seen in the lightly hydrogenated products. You might wonder how high oleic soy can have more stability than high oleic sunflower, which has an even higher oleic acid content. It's the result of an ideal combination of a high oleic content and a high amount of naturally occurring antioxidants, which are the tocopherols found in soybean oil, that result in high oleic soy's superior stability. High oleic soy, just like conventional soy, has the highest concentration of these important antioxidants. In addition, soy has the highest amount of delta and gamma tocopherols that offers better protection to an oil than the less stable alpha and beta varieties. When we look at high oleic soy's performance in food service, one test that is usually performed is a fry test comparing it to different oils. Fry tests performed by various companies and industry organizations have demonstrated that high oleic soy achieves a 2 to 3 times longer fry life when compared to conventional soy. This translates directly into fewer oil changes and lower annual operating costs. You'll also be providing your customers with better tasting and less greasy foods due to the reduced oxidation. There is also notably less foaming in the fryers. Another added benefit is that you will have fewer empty oil containers to dispose of afterwards. We're all familiar with the real-world consequences of oil oxidation, from cleaning and maintenance issues to excessive foaming in fryers, and of course the resulting rancid flavors and off odors. Polymer formation is a direct result of oil oxidation, and lower polyunsaturates equates to less polymer formation. It's this polymeric material that leads to an increase in the oil viscosity along with performance deterioration. As you can see by the photos on the right, high oleic soy has significantly less polymerization, which allows for easier fryer cleaning, decreased equipment maintenance, and less greasy film buildup, leading to improved facility cleanliness. The neutral flavor and exceptional stability of high oleic soy also provides an excellent opportunity to blend with other oils. For food companies that may prefer a certain oil's flavor in their finished products, they can still improve its stability by blending it with high oleic soy. This graph shows how OSI values for corn, cottonseed, and peanut oils were increased when blended with high oleic soy, especially once the blend ratio reached 50% or greater. I'd also point out that there could be a price advantage by blending with high oleic soy, especially if it's olive oil. When we look at how high oleic soy can be used in food service, the applications are almost unlimited. Certainly, it's an excellent restaurant deep frying oil, or as a pan grill oil for sauteing or stir frying, or even used as an anti-stick spray or as a popcorn oil. It can also be used to make salad dressings, sauces, mayonnaise, in addition to making blends with olive and other oils. We also see it being used for donut frying along with cake and icing shortenings, and has potential in the retail bottle market, where its desirable nutritional profile and clean, neutral flavor can offer consumers direct benefits. Here are some examples of the high oleic soy products that are currently being sold in the U.S. food service market. Quite a few of these frying oils being sold are in fact a blend with commodity soybean oil. This provides a more economical offering for customers who are price sensitive, but also want improved performance in their fry oil. The bakery shortenings used high oleic soy are being made with a new blending technology. This new class of bakery shortenings, where solid fats are required for specific functionality, are made using enzymatic interesterification. This effective processing technique rearranges the fatty acids within the triglyceride molecule of the different oils being blended. Using this process, liquid high oleic soy oil is combined with a hard base stock, such as fully hydrogenated soy or cottonseed oils, which does not have any trans fats, or palm oil to achieve the desired melt curve. And unlike hydrogenation, this process does not result in the formation of trans fatty acids. This allows refiners to offer superior solutions for food and bakery applications where zero trans fat, solid or semi-solid shortenings are needed and are now a drop-in replacement for the old partially hydrogenated types. And because high oleic soy has more solids at cooler temperatures, this allows a reduced saturate content without compromising the shortening's functionality. Turning to applications in food manufacturing, high oleic soybean oil is ideal for industrial par frying of frozen potatoes, chicken and seafood products, instant noodles such as ramen, and as a frying oil for salty snacks such as potato or tortilla chips, roasted nuts, and as a coating oil for extruded products such as cheese puffs. In baked goods, it can be used as a spray oil for crackers and the base oil in shortenings for cookies, icings, and frostings. It's an excellent shelf life, makes it ideal for use in breakfast and nutritional bars and in breading and batter dry mixes. Currently, the single largest use for high oleic soybean oil in the US is in liquid non-dairy creamers, such as Nestle's coffee mate products. For the same reasons high oleic soy is excellent in food applications, it's also proving true in non-food markets. Today, many consumers are looking for renewable, bio-based alternatives to those made from petroleum, and that also provide for better environmental stewardship while still maintaining or improving the product's functional properties. High oleic soy's excellent heat and oxidative stability is opening new markets for soybean oil, such as industrial and lubricants and greases. It's being used to make marine oils, cutting oils, transformer oils, chainsaw and machine lubricants, hydraulic fluids, and even railroad greases. Tire companies have discovered that by using high oleic soybean oil as an ingredient in rubber formulations, it keeps the tire tread softer at cold temperatures, which improves the tire's traction capabilities in winter conditions. For the same reason, it can also be used in manufacturing high-performance racing tires, where the improved traction with the racetrack is a definite advantage. Research recently completed by Iowa State University and the United Soybean Board has resulted in an improved asphalt binding agent that offers an improved and lower cost alternative to the petroleum-based polymers traditionally used. High Oleic soy oil makes the polymers have better elastic properties, making it more resilient at high temperatures and resistant to cracking at low temperatures. In addition, it increases the reuse rate on asphalt grindings from 17% to more than 30%. For the oleochemical industry, High Oleic soy offers a rich source of oleic acid, which provides better uniformity in addition to reducing separation costs in comparison to beef tallow. A U.S. company, Biosynthetic Technologies, has recently introduced a High Oleic soy-based motor oil that is a drop-in alternative to traditional petroleum-based motor oils. Not only does this high-performance oil keep engines cleaner by reducing sludge and varnish deposits, which you can see clearly in the photos on the lower right, but it also increases fuel economy by 3%. And before commercializing, the oils were extensively tested at the U.S. Department of Defense locations, including the Air Force, Army, Navy, Homeland Security, and even NASA. So you can see that High Oleic soy offers opportunities in multiple industries and product applications. Today's consumers often want to know whether the food they eat was produced in a sustainable manner. This is easily satisfied since High Oleic soybeans are also included in the U.S. soybean industry's Sustainability Assurance Protocol. U.S. soybean growers are committed to being stewards of the land they farm. This includes a variety of sustainable practices to reduce their overall land use, soil erosion, energy use, and total greenhouse gas emissions, along with improving water use efficiencies. These practices allow for independently audited programs that verify U.S. soybeans are produced in the most sustainable manner. The improved frying and shelf life benefits of High Oleic soybean oil allows for an even better sustainability advantage over other competitive oils when you calculate in total reduced oil used in the fryers, less packaging, and the reduced amount of food discarded because it had gone bad. Many consumers also want to know where food ingredients originate from, who grew them, and where they were grown. The closed-loop, identity-preserved supply chains and production contracts used with individual farmers allows High Oleic soy suppliers to offer a very compelling traceability story that can be used in end-user marketing. So to wrap up, here are the primary marketing opportunities you can consider with High Oleic soy. It provides a 2 to 3 times longer fry life. With fewer oil changes, this saves money on your annual oil cost. With less residue on your fryers and equipment, there's less labor costs and associated downtime for cleaning, along with extending the life of your equipment. It provides a very neutral and clean flavor that makes for attractive blending opportunities with other oils and allows you to optimize the functionality, flavor profile, and cost for the resulting blended oil. With a high oxidative stability, it's an excellent oil choice when considering the packaged shelf life challenges, especially in warmer climates. And as a new oil, High Oleic soy provides a great marketing opportunity to expand your soy product line offering and bring your customers more healthful, sustainable, and traceable foods that also taste great. And equally, if not more important than all of the above, U.S.-grown High Oleic soybean oil is the most affordable, high-stability oil available from the North American market. Additional High Oleic soybean oil information, along with functionality testing results, case studies, and end-user testimonials can be found on the QualiSoy and USSEC websites. In part 2 of High Oleic soy series, I will focus on sourcing and supply chain considerations. Thank you for your time and attention, and I hope you now have a better understanding why High Oleic soy is such an exciting new product brought to you by the U.S. soybean industry.